Welcome back. At this point, we've built an app that can count numbers, state, and display pictures, images. But visually, it's a mess. Elements are smashed against edges on the screen or stuck awkwardly in the center. It looks like a prototype, not a product. To fix this, we need to master the most versatile widget in the entire Flutter catalog, the container. If you are coming from web development, you can think of container as your div, but on steroids. The container is your go-to tool for three things. Painting, adding background colors, borders, shadows. Positioning, moving elements around with margins. And sizing, controlling width, height, and internal spacing via padding. So to do this, we look at box model. In the innermost layer of the box model, you have your content. Outside your content, the first layer that you have is your padding. So if you increase your padding, your content gets smushed towards the center. If you decrease your padding, your content has more space to breathe or scales up. Outside padding, you have your border. So border is the next visible element on your screen aside from content. Padding is usually a transparent element that is usually just used to manage spacing. And to top it all off, you have your margin. So margin is the outermost layer of the box model that separates one box from another box. So let's say if I had two contents side to side, what would separate them from each other? Obviously you'd have the border, but if you stuck the border to each other, they'd practically be indifferentiable. So you have margin. Margin is the space between borders. So in the box model, generally your margin and your padding are invisible elements, and your border and your content are the visible elements. The biggest point of confusion for beginners is the difference between padding and margin. We're going to visualize this in code today so you never mix them up again. Let's head into the IDE. I have our image from the last episode. It's just floating in the center. Let's wrap this image in a container to see what we can control. Let's have a look at our application first. So this is the image that I have in the center. Now I want to wrap this in a container to see what I can control. So first of all, instead of directly passing image asset as a child, what I want to do is I want to pass a container as a child. So inside container, I can have another child, and in this child, I want to pass in the image. So if you remember, it's image asset, then you give your source, which is assets, images, logo.png. So currently, if you run this code, nothing happens. Visually, a default container is invisible. It simply hugs its child tightly. To see the container, we need to give it paint. This is actually my number one tip for debugging layout issues. If you don't know where a widget is, give it a bright color. So for this example, let's give our container a color. Let's give it a bright color like red. So if you remember how to give your color, you do not simply type red, you have to type colors.red. Don't forget the comma. If you perform a hard reload and go back to your application, now you can see this red box. It's the exact same size as our image, and the container effectively shrinks to fit its content. Now we can dictate the size of a container. If I want to change the size of the container that is hugging our image, I simply pass in width. Oh, don't forget the comma. If I perform a hard reload now and go back to my application, you can see that I've got hard-coded the width and height to 300. The red box, which is our container, is smaller than our Flutter logo. So the container has taken control of the layout constraint. It made the logo, which is inside the container, also shrink alongside the dimensions of the container. Now for the main event, spacing. We can use edge insets to define a class space. First, padding. Padding is the space inside a container. It pushes the child away from the walls of the container. So to add padding, you simply write in the property padding and give it a value. So before we give it a value, you cannot directly apply a value to padding. You have to define what kind of padding it is. And to do this, we use edge insets. So if you type in edge insets all, then it will give a padding everywhere. There are multiple properties of edge insets. So you can do edge insets only to give a padding only to top, left, bottom, or right. Or you can use from LTRB to give left, top, right, and bottom individually. Let's start with all. So it expects a value. Let's give it a value of 20. So if I save this now and come back to my logo, you might not see much of a difference. Let me put this on top so that you can visually see the difference. If I change my padding to 0, so basically no padding, opposed to if I change my padding to something like 50. So you can see the logo is shrinking or the logo is expanding based on the padding that I give, because padding is this space between the logo and the container. So the more padding you have, the more space that you'll have before the border kicks in. Now, edge insets.all is one example. You can have edge insets dot only. So if I want only padding on the top, I can give edge insets only with a value of 50, let's say. I need to define which. So you need to define either you're giving top, left, right, or bottom. So if I want to give a padding of 50 to only the top side of this container, I'll type edge insets only top 50, perform a hot reload, and you'll see that padding has only been applied to the top. This might be useful depending on your use case scenario, but that's how padding works. The background stays the same size, but the image actually squeezes inwards by 20 pixels, or in this case, 50 pixels. So that is what padding is. The object or any element that you place inside the container that contains the padding will be shrinked, whereas the container remains the same. Now let's talk about margins. So margin is the space outside the container. It pushes the container away from its neighbors. So the margin is this space, all of this space outside the container. So it's hard to visualize margin when your object is centered because it's pretty much far away from any other element by default. So handy thing in Android Studio is you can select a widget. And if you click on this button, you can delete that widget without having to deal with any broken errors or any broken closing statements or any commas or such. You can simply reverse it by Ctrl Z, but you can click on a widget, click on this toolbar, and simply click remove widget. So if I hot reload this, then since this container is no longer centered to the screen, it will be by default aligned to the top left of the screen. Why did I do this? This is to better visualize what margins are. Since we changed the padding, the container itself never moves. The object or the elements inside the container moves. But what if I want this container to be away from the elements around it? So I want a certain gap between my app bar and my container. My app bar currently doesn't have a color, so let's give my app bar a color. It's background color. Obviously, you'll have much prettier colors in your actual designs, but this is just for demonstration. If I perform a hot reload, you can see that my container is tightly stuck to my app bar. If I want a gap here, what I will do is either I can give a margin to my app bar or I can give a margin to my container. I'll show it to you by giving a margin to my container. For now, I'll remove this padding and perform a hot reload, which resizes my logo to its original size. Let's remove this width constraint too, so my container is now hugging my actual original image and not resizing it at all. If I want a space on top, what I can do is give a margin property and inside edge insets dot the same as padding. So only, all, from, or 0. If I want to give padding just to the top, then I can do only top and give a value for margin. This will move my container 50 pixels away from anything around it on the top. Notice how the box itself moved. It pushed away everything from around it. Padding is internal cushion and margin is like personal space. I used top 50 here, but generally you don't want a specific spacing only for a specific area. Either you want something that's like symmetric. So if you add symmetric, it will add padding to top and the bottom itself, or left and right itself. So for that, you either give it a horizontal symmetric or a vertical symmetric, or maybe both. So in this case, not only does it push it away from the top, but from the bottom too, from the left too, from the right too. If I were to place another element, it would appear exactly the same distance from the edge of the application as from the right edge of this container. Finally, we want to make this look nice. Maybe some rounded corners, a shadow. To do this, we use the decoration property. Watch closely. I want to add a border radius to this box, so I add something called a box decoration to my container. I have to add a decoration property, and inside it, I'll pass a box decoration widget. In my box decoration widget, I can have a property called border radius, and inside border radius dot, you can have many types of radii, but I'll use a circular border radius and give it a value of 20. What happens if I hot reload this? And we crashed. Let's read our crash message. Color equals to null, decoration equals to null. Cannot provide both a color and a decoration. So the error is pretty self-explanatory. The rule is if you provide a decoration, the color must be inside that decoration. You cannot have both a standalone color and a decoration in the same container. So if we simply move this color into our box decoration, the error should be fixed. And there we go. We have a nice looking border around our box. You can simply go through the Flutter documentation for more properties of the box decoration widget. I'll use some here now. You can have a border itself with border.all, so that you have border on the top, left, right, and bottom. Inside border.all, obviously you can have a color, and you have a border width. If I perform a hot reload, then I'll have a width of 2 pixels all around in the color black. You can also have something called a box shadow. So a box shadow, make sure that you're closing your brackets properly so that you do not create properties inside of other properties. This might be tricky at first, but you'll get the hang of it. Box shadow can have a few things. So a box shadow needs to be a list. Inside the list, you'll have a widget box shadow, and inside the widget, you have a few properties. So you can have a color of the shadow, gray. You can have a blur effect that they normally have on shadows, or you can have something called spread radius. You'll see this in effect once I hot reload this. You can have a blur radius and an offset. If I perform a hot reload, you can see that the spread radius is how far it spreads from my original box. The blur radius is how much to blur it. So if I set my blur radius to 0, this won't be blurred at all. It'll simply just appear gray. The more you increase this, the more blur it seems. The offset is how much it moves from the center. So on my x-axis, I'm offsetting it by none, and on my y-axis, I'm offsetting it by 3. Now this may not seem very visible, but if I change it to a ridiculous value like 50, you can see that on the x-axis, it did not change at all. So x is your horizontal axis, and on the y-axis, it moved down 50. If I change it on x-axis too, you can see that it moves on the right. So you'll notice that in applications, your y-axis increases when you go down, and your x-axis increases when you go right. So your exact 0, 0 or point of origin is on the top left portion of your screen. This is your origin. Since there is no point above this, when you go down, you increase in y. When you go right, you increase in x. Now, in this case, as I said before, I moved the color inside, so there's no error. I've added a border radius for soft corners, a black border line, and a box shadow to give it some more depth. Now, this is a UI element. It has shape, it has depth, it has proper spacing, and you can customize this however you'd like. To recap, the container is the workhorse of Flutter layouts. Let's review the key takeaways. Container is used for sizing, painting, and positioning of elements throughout your screen. Padding. It basically adds space inside the box, which in turn shrinks your content, moves it away from your border. Margin. It adds space outside the box, it physically moves the container itself, and it adds space in between different containers. Box decoration. You use it for styling. You can have corners, shadow borders, you can have colors. And the most important thing, remember that if you're using a decoration, then all the decorative properties such as color will have to be inside box decoration. So if it's outside your box decoration, your app will crash. We've mastered the single box, but apps are usually made of many boxes. We need to stack them vertically like a list or arrange them horizontally like buttons. In the next episode, we are going to learn the two most important layout widgets in existence, the rows and the columns. This is how we actually build full screen layouts. See you there.